right, welcome back from winter break. We are moving on in Unit 7. Today we're talking about probability. This is notes number 4. At the top, we're just going to do a basic review of what probability is. Let's say we roll a fair number cube, a die, and we're going to find the probability of each of the following. Remember that on a fair number cube, there are 6 possibilities, numbers 1, 2, 3, 4, 5, and 6. So what's the probability of getting a 2? There's one way that you can get a 2 out of 6 ways total, so your probability is 1/6. For part B, the probability of getting an even number, we need to think of how many even numbers there are. There's the number 2, 4, and 6, so there's 3 successes. So 3 out of the 6 total, or 1/2. So our probability of getting an even number is 1/2. Probability of getting a prime number, think of what the prime numbers are. Prime numbers from 1 to 6 are 2, 3, and 5. And so there's 3 of them. 3 successes. 3 successes out of 6 total is the same thing as 1/2. So basic probability, looking at the number of successes that you have out of the number of total outcomes. Now, let's say we're going to roll the number cube twice. We're going to roll it twice. So find the probability of each of the following. Probability of getting 2 4s. Probability of getting a 4 the first time is 1 out of 6. That's the first time we roll the die. Then we pick the die up and we roll it again. And again, the probability of getting a 4 is 1 out of 6. So that's the first roll. This is the second roll. And to find the probability of both of those happening together, I'm going to multiply. 1/6 times 1/6 is the same thing as 1 out of 36. The probability of getting a 2 and then a 3, if I'm going to get a 2, that means my probability is 1 out of 6. A 3 is also 1 out of 6. So 1/6 times 1/6, 1 out of 36. Okay. Probability of rolling a 1 and then any number, then we don't care what the second number is. So if we roll a 1, that probability is going to be 1 out of 6. But the second time when we roll the die, we don't care what the number is, we're looking for any number. So there's 6 successes out of the 6 outcomes because any one of those will work. 1/6 times 6/6 is 6 out of 36. Reducing that, we get 1/6. So there's our probability. And like I said, probability is known as the number of successful outcomes divided by the number of total possible outcomes. So the notation right here, probability of rolling a 4, there's 1 success and there's 6 possibilities, so it's a 1 out of 6. Okay, and this is just an example for you. Now, there's a concept of independent and dependent events here. We have to determine are our events going to be independent of each other or are they dependent of each other? Independent events are events that have no impact on each other. The result of one event has no impact on the result of the other. So for example, rolling a die and drawing a card from a standard deck. When I roll a die and pull a card from a deck of cards, they don't have anything to do with each other. One is not affecting the other. That's what makes them independent. Dependent events, however, now the result of the first impacts the result of the second. So for example, drawing an ace, then drawing a 4 from a standard deck without replacement. If I'm going to draw an ace out of a standard deck, I have 4 aces out of 52 cards total. But without replacement, meaning I don't put that back, now I only have 51 cards left. It changed my probability. I'm trying to draw a 4, there's 4 4s, but my probability changed from one to the next because I didn't put that card back. That makes it dependent. So we have to determine, are they going to be independent or are they going to be dependent? Let's just do some examples of identifying these. In the first one, it says choosing the color and size of a pair of shoes. If I choose the color and size of a pair of shoes, does the color have to do with the size? No. if I choose a color, that has nothing to do with what size that is. So this is going to be independent. Okay. If I look at number 2, choosing the winner and the runner-up at a dog show, when I choose the winner out of the group of dogs, that dog is now done. So I have a lesser number of options to choose the runner-up. That changes my probability, meaning these are dependent. Because after I choose the winner, now I have a different number of dogs for the runner-up. In number 3, choosing a president, vice president, secretary, and treasurer for student council, assuming that everyone can only have one job. Again, I have a group of people. I'm going to pick the president. Once I pick the president, now my group of people that are left has changed because there's one less person. Then I'm going to pick the vice president. Then it's going to change again. Then I'm going to pick the secretary, changes again. So one event is affecting the other. This is also dependent. I want you to pause the video at this point and see if you can decide about number 4. In number 4, you're going to select a fiction book and a nonfiction book from the library. You determine, is that independent or dependent? If we move on and look at calculating some probability examples, number 5. At a picnic, Julio reaches into the ice-filled cooler. He's got 8 regular soft drinks and 5 diet soft drinks. He's going to put the drink back because he decides he doesn't want it, and then somebody else is going to come to the cooler and pick out a soda. Okay, now the key phrase in here is he puts it back. So if he pulls out a can and puts it back into the cooler, the probability has not changed. The number of cans that are in the cooler has remained the same. This is independent. These two things have not affected each other. Now to calculate this probability, I need to first look at how many total drinks do I have? 8 plus 5. Okay, so 13 total cans. And then I need to look at my successes. We want a regular soft drink, and there's 8 of those. So for Julio, the first person, he has an 8 out of 13 chance of picking out a regular soft drink. He's going to look at the can, put it back in the cooler. Someone else walks up. They also have an 8 out of 13 chance of picking out a regular soft drink because the can was put back. So if I take these two and I multiply them together, that means I end up with 64 out of 169. Or you can write this as a decimal. Typically, we want to round these out to the third decimal place, so that would be 0.379 in this case. There's your probability. Let's look at number 6. Now we're pulling 3 cards from a deck without replacement. Find the probability of drawing a heart, another heart, and a spade in that order. Well, one good thing to know is how many are there of each type. There's 52 cards total, and there's 13 of each type. So there's 13 hearts, there's 13 clubs. I can't draw a club, I'll be honest. There's 13 diamonds, and there's 13 spades. This one I could try. Ooh, there we go. All right, so that's the standard deck of cards that we're working with, just in case you are not familiar with that. Now, key phrase in this question, without replacement, meaning I'm pulling out a card and I'm not putting it back. Okay, I'm pulling out a card and I'm not putting it back. So I'm trying to draw a heart, another heart, and a spade in that order. For the first one, I have 13 hearts out of 52 cards. Now, if I don't put that back, how many cards are left in the deck? Only 51. So there's only 51 cards left in the deck, and I've already pulled out a heart. So now there's only 12 hearts left. And then I don't put the second card back, so now there's only 50. And I'm looking for spades, which there's 13 still, because I haven't touched the spades yet. These are events that are affecting each other. These are dependent. Now let's just review fractions here for a second. When I am multiplying fractions, I want to go straight across the top and straight across the bottom, and then divide at the end. Okay, so 13 times 12 times 13 is 2028. Let's change that color. And 52 times 51 times 50 is 132,600. I can turn that into a decimal. Again, I'm going to round to the nearest thousandth. So that's 0.015 for my probability. Okay. I want you to pause the video for a second and see if you can try number 7, looking at the chocolate bars. So see if you can answer the question in number 7. For number 8, now we're looking at a lottery game that has 3 cages with 10 numbered balls in them. So we need to figure out the probability of the first 2 being even and the third one being prime. Okay, the first 2 being even and the third one being prime. So the first thing I need to know is what are the prime numbers. Prime numbers from 0 to 9 are 2, 3, 5, and 7. Okay. The other thing I need to consider is what are the numbers that are even. Now, normally 0 doesn't fit into either category, but in this case, we're going to call 0 an even number, because if it has to be either even or odd, we're going to put it in the even category. So we've got 0, 2, 4, 6, and 8. 5 even numbers there. Okay, so there's 3 cages, and the balls in each cage are all separate. So if I take one out of the first cage, I don't change the probability of the second cage. Therefore, these events are going to be independent of each other. One is not affecting the other. So the first one being even, that's going to be a 5 out of 10 chance. The second one being even, that's also going to be a 5 out of 10 chance. And the third one being prime, there's 1, 2, 3, 4 prime numbers, that's 4 out of 10. So I multiply those all out, and my decimal becomes 0.1. Okay. One last question that we're going to do together, number 9. Find the probability of drawing 3 cards of the same suit without replacement. Without replacement, meaning we are not putting the cards back. Again, you can already determine if you're not putting the cards back, then the second time you pick a card, it's going to be different. So these are going to be dependent. And we are trying to pick out 3 cards of the same suit. Now remember before, there's 13 cards in each suit. There's 52 total. So if I look at my 3 cards, there's a 13 out of 52 chance that I get one from one suit. I want the same suit, but now there's only 12 left out of the 51 cards total because I kept the first one out. Then there's only 11 left out of the 50 total, because I kept the second one out. So again, these are dependent, they're affecting each other. So multiply those all out, and I get a probability of 0.013. And again, you can check these on your calculator, make sure you're getting the right answer here, and go from there. I want you to pause the video and look at number 10 on your own, see if you can answer that question. And when you are finished, don't forget to go take the quiz. Hop onto Schoology and go back and take the quiz. Thanks and have a great night.